Hello guys, welcome to Solving Solutions, your number one channel where I get solutions to all your solving problems. It's nice having you in class again today. How have you been? On today's tutorial, we are going to show you how to determine or identify UTM zones of points, right? Good. Now we have a set of points here, points A to point H, and then we have the longitude and the latitude values, and then we have used the first and second approaches because we are going to look at two approaches on today's tutorial to try to determine their UTM zones, right? Good. So the first thing to note is that the UTM zones are based on longitude. So having determined that, we are still going to validate our point using QGIS. So there is a file that we are going to load that will help us identify whatever zone we are. So we can now compare the calculation we have done here with what that value in the file would return, right? Good. So we have told the UTM zones are based on longitude, and then the Earth is divided into 60 UTM zones, right? Good. And then each of them is 6 degrees of longitude, right? Good. So and then the numbering starts at 1 at the 180 degrees west meridian, right? Good. And increases as you move eastward. So these are some basic stuff to note. Now the first formula to use is equal to the longitude plus 180 divided by 6. Now if you look closely, there is what we call ceiling. This almost not closed bracket, squared bracket, they call it ceiling. So now in mathematics, the ceiling function returns the smallest integer that is greater than or equal to a given real number. So to explain it further, the ceiling function takes a number and rounds it up to the next whole number. So let's say when you have your longitude, because we have told you earlier that your UTM zone is based on your longitude, right? Good, the longitude of a point. So let's say when you take your longitude, you add 180 to it and you divide by 6, and you have something like 10.2. You know, 10.2 normally, if you want to approximate to the nearest whole number, is supposed to be 10, right? Good. But because of this ceiling effect, when you have something like 10.2, the UTM zone of that point is 11, because it takes any number and rounds it up to the next whole number. So 10.1, 10.2, which are not equal to 0.5, where we can round up to the next whole number, we still do round it up to the next whole number. So that's how this first formula works, using the ceiling function. So we now have to use this example where we have a minus 45 degrees as the longitude of a point. So if we have minus 45 degrees as the longitude of a point, we have minus 45 plus 180 using the formula, right? Good, because the formula says the longitude plus 180 then divided by 6 rather. So we have 22.5. So as we have told you, this 22.5 is taken as 23, not because the decimal is is equal to or greater than 0.5. If this value were 22.1, we will still have our UTM zone to be 23. So however, because of the ceiling effect, the UTM zone is 23 degrees south. Now we have told you south here and not north, right? Good. So we are going to explain why it is south. Now it is south because the latitude is negative. So when you have calculated the zone, when you have identified the zone using the longitude, you would know if it is the northern hemisphere or the southern hemisphere using the sign of your latitude. So we have something like this here, where we say generally the distinction between the north and south in the UTM is determined by the latitude of the point. So if it is north, it refers to UTM zone in the northern hemisphere, and then if it is south, it refers to the UTM zone in the southern hemisphere, right? Good. So if we come to our point, which is the first one, you are going to see that the longitude is negative and the latitude is also negative. This now implies that the coordinate is in the southern hemisphere, right? Good. So we have 23 degrees south, and then we have told you that it's because our latitude is negative, right? Good. So that is how you identify the UTM zone. So this is the first approach, and now the second approach uses a different formula that says the UTM zone is equal to 31 plus the longitude of the point divided by 6, right? At this point, you take the integer value before the decimal as the UTM number. In this first approach, what you do is that you round up the value that you have, the number you have, and you round it up to the next whole number, right? Good. So you consider everything. However, in this second approach, when you have a whole number in front of a decimal, the UTM zone is actually that whole number. That's the integer value, right? Good. So we are still using our minus 45 degrees. So if we bring it down here, we have if we substitute into the formula, we have 31 plus the longitude over 6, which should now be, let's get our calculator again. So we now have minus 45 over 6, which is minus 7.5, right? Good. Now plus 31, that returns 23.5. So according to the logic behind the second formula, your UTM zone is the integer value before the decimal point. So the UTM zone is 23, right? Good. So we are not rounding up and then we are not rounding down. We are just taking the whole number, right? Good, which is 23. So here, taking the integer value before the decimal, we have 23. Hence, the UTM zone is 23 degrees south. So it is still south because our latitude is negative. So generally, we have explained this. What we are now going to do is that, you see, we have a set of points here. We are going to visualize them on QGIS, and then we'll also load that file that will help us identify, so that we can now validate what we have calculated. So come to layer, add the limited text, browse, open. The X is the longitude, the Y is the latitude, and then the geometric coordinate reference system is WGS 1984, because we are dealing with geodetic coordinates, right, or geographic coordinates. So we add. The next thing we also want to add is the OSM base map. Double click on that to add it. We'll need it very soon. So we can also add the Google hybrid, right? Good. So we have our points here. Let's change the symbology to good. So you can see our point reddish. The next is for us to load the file that contains the UTM zones. Good. So it's a vector data. Just add, and then we have it out here. So we also need to do a few modifications to the symbology. And then for the labeling, which will now show the zones, click on OK. Good. So you dock the attribute table of your points, and then you select each of the points. Now we're on point A, right? Good. So let's zoom to where that point A falls. You see now this is the point A that is selected. So when we zoom in, we are going to see that the UTM zone identifier identifies it as zone 23, and then from our calculation we still have zone 23. So if we do that for point 2, still zoom to layer, this is where it falls, and then the UTM zone identifier identifies it as 38, and then from our calculation we also get 38. Let's see point G. We zoom to layer as well. So this is how we have 32, and then it's also 32. So this is how you calculate the UTM zone of a point, and then by extension you can also validate what you have calculated, just as we have done, to confirm if the zones that the first approach and the second approach, which are actually conforming, would also conform with this other UTM zone identifier. So yes, thanks for coming to class. We hope we have exhaustively provided solution to this particular GIS or geodesy related problem, whereby you need to identify the UTM zone of a point using the longitude, and also to know which of the hemisphere it falls using the latitude, if it is positive or negative, whether if it is north or south, right? Good. So we are going to see you on the next tutorial. Ensure you keep staying safe and have a very good time. Bye.